Hello viewers, in today's session we are going to discuss another important problem from differentiation. And here we have to solve this problem in which we are given three functions, f of x which is equal to square root of x square plus 4, g of x that is equal to x raised to 100, and h of x is equal to x square plus 4. And we have to find the value of this expression, that is f prime of h double prime of g prime of x. So to find out the value of this expression, what we will do, we'll first find g prime of x, right? So first we'll find the derivative of g of x with respect to x. So g prime of x is equal to d by dx of g of x, and this is d by dx of x raised to 100, right? And the derivative of x raised to 100 is 100 x raised to 100 minus 1, that is 100, and x raised to 99. So here we have used this result, that is the power rule for differentiation, that is nx n minus 1, right? Okay, so once we have got g prime of x, let us find out the second derivative of h of x, because here we have h double prime. So h prime of x is equal to d by dx of h of x. So we have d by dx of h of x is x square plus 4, and here the derivative of x square due to this result is 2x, and the derivative of 4 is 0 because 4 is a constant, and the derivative of a constant is 0. So here we have simply 2x. Now the second derivative of h of x is given by d by dx of h prime of x, and h prime of x is equal to 2x. So we have d by dx of 2x, and here we have 2 times the derivative of x, and the derivative of x is 1, so here we have 2. So now let us find out the derivative of the function f of x. So f prime of x is given by d by dx of f of x. So we have d by dx of f of x is square root of x square plus 4, right? And here we can write d by dx and x square plus 4 raised to a half, right? So here again to get the derivative of x square plus 4 raised to half, we'll use this result. So we have half, and then we have x square plus 4 half minus 1, and by chain rule we have d by dx of x square plus 4, right? So this is half, and we have x square plus 4 raised to minus half. Half minus 1 is minus half, and the derivative of x square plus 4 is 2x, right? So now this 2 and this 2 get cancelled, and we are left with x over x square plus 4 raised to 1 over 2. So once we have obtained all these derivatives, let us write this expression. So we have f prime of h double prime of g prime of x, right? So now let us substitute the value of g prime of x. So we have f prime, then we have h double prime of g prime of x is equal to 100 x raised to 99, right? Okay, so now we have to find out the value of the second derivative of h of x, which is h double prime, when the input is 100x raised to 99. So now from the second derivative of h of x, we see that h double prime of x is equal to 2. And this is a constant function. And here, when we take any input that is, say, 100 times x raised to 99, then h double prime of this expression is equal to 2, right? Because whatever be the value of x, h double prime of x is always going to be 2, right? So when we take the input 100x raised to 99, then we have h double prime of this expression is equal to 2. So we can now write f prime, and here we have this expression is equal to 2, right? So we have f prime of 2. So now our aim is to get the value of f prime of 2, and f prime of x is given by this expression. So f prime of 2 can be obtained by replacing this x by 2. So we have 2. Here we'll take x is equal to 2, and here we have 2 square plus 4 raised to half, and this is 2 over this is 2 square is 4, 4 plus 4 8, 8 raised to half. So we have 2 divided by 2 times square root of 2, because the square root of 8 is equal to 2 times square root of 2. Now this 2 and this 2 get cancelled, and we are left with 1 over square root of 2. So the value of this expression is equal to 1 over square root of 2. Hello viewers, in today's session we are going to discuss an important and conceptual problem from continuity and differentiability of functions. Right? So here we are going to discuss this problem in which we are given a function f of x, which is equal to the greatest integer of x plus 3, and we have to see the continuity and differentiability of this greatest integer function, that is greatest integer of x plus 3. At this point x is equal to 1 over 3, right? So here we'll see the steps how we can prove the continuity or the discontinuity and the differentiability or the non-differentiability of functions using the given concepts, right? So let us start. So let us first see the continuity of this function. And here to prove the continuity of a function at a given point, say x is equal to a, and if we are given a function, say y is equal to f of x, what we do, we find out the right hand limit and the left hand limit and the value of the function at the given point. Here the point is x is equal to a, and if all these three quantities are finite and they exist and they are equal to each other, then we can say that the function or the given function is continuous at this point x is equal to a, right? So in our case we are given this function and the point x is equal to 1 over 3 is a, right? So let us first find the right hand limit, and then we'll find out the left hand limit, and then we'll find out the value of the function at a is equal to 1 over 3. So the notation for the right hand limit is given by limit x tends to, here we'll write a, and here we'll write a positive sign, and here we have f of x. So a is 1 over 3, so we have x tends to 1 over 3 positive, and here we have f of x, right? So let us take x is equal to 1 over 3 plus h, where h is a very small quantity, or it is infinitesimally very small, right? So here we have x is equal to a is equal to 1 over 3. So when we calculate the right hand limit, we approach from the right of x is equal to 1 over 3, and we are in the neighborhood of x is equal to 1 over 3, that is the right neighborhood, and this point is 1 over 3 plus h. And when we calculate the left hand limit, then we approach from the left of x is equal to 1 over 3, and we reach at a point in the left neighborhood, that is x is equal to 1 over 3 minus h, right? So we take x is equal to 1 over 3 plus h for calculating the right hand limit, and here when x tends to 1 over 3, then h tends to 0, and remember h is a positive quantity, and it lies between 0 and 1, right? So now the right hand limit can be written in terms of h. So we have limit h tends to 0. For x tends to 1 over 3 positive, we have h tends to 0, and here we have f of x. X can be replaced by 1 over 3 plus h. So we have limit h tends to 0. F of 1 over 3 plus h can be obtained by replacing this x by 1 over 3 plus h. So we have greatest integer of 1 over 3 plus h plus 3, right? So now we can simplify this expression. Then we have limit h tends to 0, and here we have 1 over 3 plus 3 is 10 over 3, and here we have h. So now let us see this term inside the greatest integer function symbol. So we have 10 over 3 plus h. Now when we divide this 10 by 3, we get approximately 3.3, and then we add h to 3.3. Now see, h is a very very small quantity, so when we add h to 3.3, then this term, that is 3.3 plus h, is greater than 3, but it is less than 4, right? So in other words, we can say that this number, that is 3.3 plus h, is lying between 3 and 4. So the greatest integer of 3.3 plus h is equal to this number 3 by definition of greatest integer function, right? So we have limit h tends to 0, and here 10 over 3 plus h is 3.3 plus h, and this is equal to the greatest integer of 3.3 plus h is equal to 3. So we have simply 3, right? Because this 3 is independent of h. So limit h tends to 0, 3 is equal to 3. So the right hand limit of this function at this point x is equal to 1 over 3 is equal to 3. Now let us calculate the left hand limit. So now the notation for the left hand limit is given by limit. Here we have x tends to a negative. Here we put a negative sign, and here we have f of x. So this is limit, and x tends to 1 over 3 negative, and here we have f of x, right? So now to calculate the left hand limit, we take x is equal to 1 over 3 minus h. So when x tends to 1 over 3, h tends to 0. So now the left hand limit in terms of h is given by a limit h tends to 0, and here we have f of 1 over 3 minus h. So now we can write limit h tends to 0. F of 1 over 3 minus h can be obtained by replacing this x by 1 over 3 minus h. So we have 1 over 3 minus h plus 3, and now we have limit h tends to 0, and we have 1 over 3 plus 3 is 10 over 3 minus h, right? So again, we have here this expression, that is 10 over 3 minus h. Now 10 over 3 is approximately 3.3, and here we have minus h. So h is again infinitesimally very small. So when we subtract h from 3.3, then this number is again greater than 3, but it is less than 4, right? So 3.3 minus h, or 10 over 3 minus h, it lies between 3 and 4. So by the definition of greatest integer function, the value of greatest integer of 3.3 minus h is equal to this number 3, right? So now here we have limit h tends to 0, and here we have greatest integer of 3.3 minus h, and this is limit h tends to 0, and greatest integer of 3.3 minus h is 3. So limit h tends to 0, 3 is equal to 3, because again here this term is independent of h. So we see that the left hand limit of this function when x approaches to 1 over 3 is equal to 3, right? Now let us calculate f of a. So f of a is given by f of 1 over 3. So we have f of 1 over 3 can be obtained by replacing x by 1 over 3. So we have 1 over 3 here and plus 3. So this is greatest integer of 10 over 3, and this is greatest integer of 3.3, right? So approximately 10 over 3 is 3.3. So again, by the definition of greatest integer function, 3.3, it lies between 3 and 4, right? So the greatest integer of 3.3 is equal to 3. So f of 1 over 3 is equal to 3. So we can see that the right hand limit, it exists and it is finite and it is equal to 3. The left hand limit, it exists and it is finite and it is equal to 3. And the value of the function at x is equal to 1 over 3, it exists and finite. So f of 1 over 3 is equal to 3. So these three quantities are equal to each other. So we can see that the right hand limit is equal to left hand limit is equal to f of 1 over 3, and this is equal to 3, right? So we can now claim that this function is continuous at x is equal to 1 over 3, right? So now let us see the differentiability of this function at x is equal to 1 over 3. So now to test the differentiability of this function at this point, we find out the right hand derivative and we find out the left hand derivative, right? And if the right hand derivative, it exists and it is finite, and similarly the left hand limit, it exists and finite, and both are equal to each other, then we can see or we can claim that this function is differentiable at this point, that is x is equal to a, right? So the definition of right hand derivative is given by this limit, that is limit x h tends to 0, and here we have f of a plus h minus f of a divided by h. So this limit gives us the right hand derivative, at this point x is equal to a. So the notation, this notation can also be used f prime, and here we write a positive sign, and here we have a. So now the right hand derivative is given by a limit h tends to 0. We have f of 1 over 3 plus h because a is 1 over 3. Then we have f of 1 over 3, right? And here we have h. So now we have limit h tends to 0, f of 1 over 3 plus h can be obtained by replacing x by 1 over 3 plus h. So we have greatest integer of 1 over 3 plus h plus 3, and we have here f of 1 over 3 is equal to 3, and here we have h. So now we have limit h tends to 0, and this is greatest integer of 10 over 3. 1 over 3 plus 3 is 10 over 3 plus h, and here we have minus 3 over h. And we have just seen that the greatest integer of 10 over 3 plus h is equal to 3, right? So while proving the continuity of this function at x is equal to 1 over 3, we see that greatest integer of 10 over 3 plus h is equal to 3. So we have limit h tends to 0, and here we have 3 minus 3 over h. So this is limit h tends to 0. 3 minus 3 is 0 over h. So that is equal to 0, right? So the right hand derivative of this function at x is equal to 1 over 3 is given by 0. So now let us calculate the left hand derivative. So the left hand derivative is given by this limit h tends to 0. We have f of a minus h minus f of a divided by a minus h, right? So this limit gives us the left hand derivative, and the notation may also be used. This notation, that is f prime, here we have a and here we put a negative sign, right? So now we have limit h tends to 0, and f of a minus h is f of 1 over 3 minus h minus f of 3 divided by minus h. So this is limit h tends to 0. F of 1 over 3 minus h can be obtained by replacing x by 1 over 3 minus h. So we have greatest integer of 1 over 3 minus h plus 3, and here f of 3 is equal to 3 divided by minus h. So we have limit h tends to 0, and this is greatest integer of 10 over 3. 1 over 3 plus 3 is 10 over 3 minus h. Here we have 3 and divided by minus h, right? So we have seen that the value of greatest integer of 10 over 3 minus h is equal to 3, right? So while proving the continuity, we have seen that the greatest integer of 10 over 3 minus h is equal to 3. So now we can write limit h tends to 0, and this is 3. So we have 3 minus 3 over minus h. So this is limit h tends to 0. 3 minus 3 is 0 over minus h, that is equal to 0, right? So we can see that the left hand derivative of this function at x is equal to 1 over 3 is equal to 0. So viewers, we have seen that the right hand derivative is equal to 0, and the left hand derivative is also equal to 0 at this point 1 over 3, and we can see that the right hand derivative is equal to left hand derivative is equal to 0. So we can now see that, or we can claim that this function is differentiable at x is equal to 1 over 3, because the right hand derivative, it exists and it is finite and equal to 0. And similarly, the left hand derivative, it also exists and finite and equal to 0. So right hand derivative is equal to left hand derivative, and both are equal to 0, right? We can also write the notation, that is f prime, and here we write a positive sign. Then we have 1 over 3 is equal to 0, that is equal to f prime. Here we write a negative sign, and here we have 1 over 3. So this is right hand derivative, this is left hand derivative, and both are equal to 0. So the function is differentiable at x is equal to 1 over 3. So from this discussion, we arrive at the result that the greatest integer function, that is x plus 3, is continuous and differentiable at x is equal to 1 over 3. Hello viewers, in today's session we are going to discuss another important and conceptual problem from differentiation related to first principle, right? So here we are going to find out the derivative of secant 4x from first principle, right? So let us start. So now let us first take this function secant of 4x as f of x. So we have f of x is equal to secant of 4x, and from the definition of first principle, we know that the derivative of f of x, which is denoted by f prime of x, or if we take y is equal to f of x, then we can write dy over dx is given by this limit, that is limit h tends to 0, f of here we write x plus h minus f of x divided by h, right? So this limit is known as the derivative of y with respect to x, and this statement is known as finding out the derivative using first principle, right? So we'll use or we'll calculate this limit for this function to get the derivative of secant 4x. So now we can write the derivative of secant 4x using this limit, that is limit h tends to 0, and remember here this h is infinitesimally very small, right? So f of x plus h, now f of x is given as secant of 4x, so f of x plus h can be obtained by replacing this x by x plus h. So we have 4 times x plus h, then minus f of x, this is secant of 4x divided by h. Now let us simplify this expression. So we have secant 4x plus 4h, and here we have secant of 4x divided by h, right? Now from trigonometry we know that secant theta is equal to 1 over cosine theta. So using this reciprocal relation, we can now write limit h tends to 0, and secant of 4x plus 4h can be written in terms of cosine function as the cosine of 4x plus 4h, and then we have 1 over cosine of 4x divided by h, right? Okay, now let us simplify this expression by cross multiplication or taking the LCM here. We have cosine 4x minus cosine 4x plus 4h divided by cosine 4x plus 4h, then cosine 4x, and then here we have the quantity h, right? So now we have to evaluate this limit. Now see, in the numerator we have the difference of two cosine functions. So now we can express this numerator, that is the difference of two cosine function, by using this result, that is cos alpha minus cos beta is given by minus 2 sine, we have here alpha plus beta over 2, and then we have sine of alpha minus beta over 2. So this is an important identity from trigonometry, right? So now applying this identity to this function, right? So here we have 4x, which can be taken as alpha, and 4x plus 4h may be taken as beta. So now we can write limit h tends to 0. We have cos alpha minus cos beta, that is equal to minus 2 sine, and then we have alpha plus beta over 2. So alpha is 4x, alpha can be taken as 4x, beta is 4x plus 4h. So here we have 4x plus 4h divided by 2, and then we have sine alpha minus beta over 2. So alpha is 4x minus beta, that is 4x minus 4h over 2, and in the denominator we have h cosine 4x plus 4h, and here we have cosine 4x. So now we can write this limit as limit h tends to 0. Here we have minus 2 sine, and see, here we have 4x plus 4x is 8x. Then we have 4h divided by 2, and taking 2 common, we have 4x plus 2h and divided by 2, so 2 and 2 get cancelled, so we are left with only 4x plus 2h, right? And similarly here 4x and 4x get cancelled, so we are left with the sine of minus 4h over 2, right? So this is 2 times 2 is 4, so we have sine minus 2h, and from trigonometry we know that sine of minus theta is minus sine theta. So here we have minus sine 2h, right? So here we can write minus sine 2h, and in the denominator we have h cos of 4x plus 4h, and here we have cosine of 4x. So now this negative sign and this negative sign, when multiplied together, it becomes positive. So we have limit h tends to 0. We have 2 sine 4x plus 2h, and then we have sine 2h, right? And in the denominator we have h times cosine 4x plus 4h, and here we have cos 4x. Now see, here we have sine 2h, and here we have h. So here what we will do, we'll try to convert this limit into this form, that is limit theta tends to 0, sine theta over theta is equal to 1, right? So what we will do, we'll write limit h tends to 0. So first we have this limit, that is sine 4x plus 2h divided by cosine 4x plus 4h, right? And then we have this factor, that is 2. We can take it outside, and then we have this expression, that is limit h tends to 0 sine 2h divided by h, right? So for converting this limit into this form, here we have 2h. So writing here 2h and multiplying the numerator by 2, this limit is now equal to 1, right? and moreover we have this factor that is 1 over cosine 4x. So now we have 2, and here limit h tends to 0, and here we have sine 4x plus 2h over cosine 4x plus 4h. So when h tends to 0, this term becomes 0, and this term also becomes 0. So we are left with sine 4x over cosine 4x, and then the value of this limit due to this result is equal to 1. This is equal to 1, right? So here we have 1, and then we have the factor 2, and here we have 1 over cosine 4x, right? So 2 times 2 is 4, and sine 4x over cosine 4x is tangent of 4x, and 1 over cosine 4x is secant of 4x. So here we have used this result, that is tangent theta is equal to sine theta over cosine theta, right? So the derivative of secant 4x with respect to x is given by 4 times tangent of 4x times secant of 4x. So viewers, this is how, by making use of the concept of first principle, we can arrive at the derivative of given function.